All right, good afternoon. This is Charlie. We're going to be talking about heat exchangers here, and we're in the Home Inspectors Helping Home Inspectors. This information was taken from Nachi, and then we also have some personal photos. With me, we're going to have on typing only is going to be James Croton, and we're going to have Jason Baker. Jason, can you introduce yourself real quick?
Yeah, howdy. I'm Jason Baker, Baker Property Inspections. I've been doing home inspections in Southwest Michigan for around 5 years. Just started my own inspection company not too long ago.
Nice. Yeah. And how many heat exchangers or gas forced air furnaces you guys got out there by you?
Mostly gas to air force furnaces. Geothermal is not very common in the area. Boiler heat is, I would say, less than 10% or even maybe less than 5% of the houses I look at. And we do have some electric heat pump style systems as primary, but most of those around here also have a forced air fuel fired backup.
Nice. And what part of the country are you in?
Southwest Michigan.
And James, type in where you're from, please. And then we'll share that. And somebody said hello to us, which is great. All right. And I'm in the Chicagoland area myself. So we're going to go and show a bunch of heat exchangers in a little bit. And I'm just going to do a little bit of an early primer, per se, on furnaces. So when we're dealing with gas forced air furnaces, the airflow and the order of airflow is what's important. Most furnaces are multi-directional, so it really doesn't matter if they're upflow, downflow, or horizontal. But what we do want to see is, number one, we want to go ahead and filter the air. And then number two, we want to send it through our blower. Number three is going to be our heat exchanger. And then if we did have an air conditioning coil, and these drawings do not, that would be last when we're dealing with the forced air furnace. With electric furnaces, which we don't really have a lot of them, those actually put the air conditioning coils ahead of time. I guess the heating elements don't have too much of an order. But I would like you to remember filter, fan, heat exchanger, and then air conditioning coils. All right. So the first thing when we look at a furnace, we should know the different components and what they do and the order of operation when we fire up a furnace. This photo is of an 80%er. And of course, I decided to put my hand in the way, which is always fun. But you should be able to recognize the inducer fan. Once the thermostat calls for heat, the computer that's inside here is going to do a quick check. And Lorain, Ohio, thank you. It's going to do a quick check, and then just to make sure that everything's connected and everybody's communicating with each other. The first thing that we're going to see is this inducer fan to start spinning. The computer doesn't know if the fan blades are broken or there's a bird in there or the motor is shot. So there's no way to know that it's actually creating a draft, except for these guys over here. You know what those are, Jason?
Those are pressure sensor diaphragms of some sort.
Yeah, their actual name is a pressure differential switch. So when these things are going, there's usually going to be a tube. And it's kind of hard to see in this picture, but there's going to be a tube that goes to the inducer fan housing motor. And sometimes it's going to be inside the heat exchanger. Sometimes it's going to be in the housing motor. So sometimes it'll be a negative pressure. Sometimes it'll be a positive pressure. But anyway, it's going to change the pressures. That's going to send a signal back to the computer saying, yep, you're good. Continue on. Then we're going to have a silicon igniter down here. Our gas valve will open up, send gas in there, and then we're going to have a flame sensor somewhere in there to go ahead and make sure that the gas actually ignited. Once that happens, it's going to send another signal back to the computer, and the computer is going to go ahead and let it go to the next stage. Then behind this hand, like a secret weapon, there's going to be a high limit switch or basically another thermostat in there. And if this blower fan is not running, then this furnace is going to get hotter and hotter and hotter until finally it's going to overheat. And then this is what's going to shut it down so that it restarts over again. And these are all the safety things that are built into it. And when we go into the high efficiency furnaces, and typically with the high efficiencies, those are going to be the ones with the PVC for the combustion air intake and the combustion exhaust. And this is typically what we're going to see. But the inside is still basically the same thing. We're still going to have an inducer fan. I will say one thing, though, the housing for the inducer fan, if you're not sure what you're looking at, if this housing is made of plastic, then this is a high efficiency furnace. If this housing is made of plastic, then my vent or vent connector has to be made of plastic as well. I can't use metal on these because the corrosion or condensation that comes out of there will eat through that metal in like 2 years or less. I mean, it's going to be really quick. And I can't put plastic on the other ones because I'm going to have 300 to 500 degrees of heat coming out of there, and that's actually going to melt those pipes. So, if this is plastic, then the pipe has to be plastic. And then if we look, we'll see our pressure differential switch there. We're going to have our burner chamber up here. The single wire coming off of there, that's my flame sensor. And then I should have an igniter in here over on the right. Obviously, my gas valve. And then way back in that corner behind the gas valve, I don't know if you see that ceramic little square in there. That's going to be my high limit sensor on that. Down here is where our condensate drain is. And we're going to talk about this and trying to, what we as home inspectors can do without any special equipment. What we can do to go ahead and find some of these issues. All right. So next thing is the heat exchanger itself. And Jason, want to share with us, what are the 3 safety things when it comes to furnaces? How do I keep carbon monoxide from coming into the breathing area?
Sure. Carbon monoxide is produced typically by poor combustion. So one of the primary ways to prevent it from building up is by having a clean burn, proper amount of oxygen to fuel ratio.
Excellent. What else?
The other is just the fact that we have pressure differentials pulling a draft, thereby pulling the exhaust gases out of the unit.
And I'm going to go in a little bit more on that. So if I have my inducer fan up here, and that's going to be blowing air upwards, I'm going to have, and just for a short bit, because it's still hot air on the mid efficiencies, but I'm going to have positive air pressure after the fan, and I'm going to have a negative air pressure before the fan. So inside the heat exchanger, it's going to be negative pressures, right? Then I'm going to put a blower fan that's going to blow air on the outside, and that's going to create a positive pressure on the outside of this heat exchanger. So let's say I did have a hole in this thing, then air is actually going to flow into the heat exchanger as opposed to carbon monoxide coming out of it. All right. And the last one is going to be the heat exchanger itself. I'm sorry, I'm stealing that one away from you.
Please, go ahead.
The heat exchanger itself. All right. Even though these things are not hermetically sealed, they're supposed to be together. They're supposed to be tight. We don't want to have any sort of combustion that travels between the breathable air and the combustion air that's being exhausted. All right. So gas air mixture, pressure differentials, heat exchangers. Excellent. What we're looking at here now, I don't know if you recognize that or not. It's the old natural draft. I refer to these as clamshells, heat exchangers. Typically, the fire is going to come in at the bottom of these things, and then it's going to bounce off this wall, bounce off that wall, bounce off this wall, and work its way up and out. And as the heat keeps bouncing off the walls, this metal is going to get hot, and then we're able to go ahead and blow air on the outside of it, absorb that heat, and bring it to the rest of the house. These are going to be found on natural draft furnaces. We're really not going to see these anymore. I honestly can't tell you the last time I ran into a natural draft furnace that, they're all going to be 30 plus years old, and most
Yeah, I see a couple of them here and there.
yeah,
People keep some of these things going for a while. Mainly, it's the big cabinets, the old tank units that I still see kind of kicking around.
like the gravities.
Yeah, like a gravity or a well, it almost seems like it would be like a boiler type flame, like a sealed combustion chamber with one of those big ceramic burners in the center.
Oh, I know what you're talking about. Yeah,
We still see some of those around here and there, like an old Bard or something like that.
nice. And then, yeah, I would love to get my hands on some of those and put those do the
Yeah.
analyzer test. When we run the analyzers on these things, we actually have to do each and every heat exchanger separately. We can't do
Okay.
them together on these things. So I'll chat on that a little bit later if you want. Second one is a Serpentine heat exchanger. There's a lot of people that actually call this a clamshell as well. When they make these, there's two pieces that go in here, and then they drill these holes right in here. And then what happens is one of them that pushes the metal through the other one, and then they bend it back over to go ahead and get the seal. And then they do the same thing along this perimeter edge out here. The weak points on these serpentines, and I'll show you pictures of these, are always going to be at these eyelets or these dimples here. And these dimples are just so that heat goes across, and it's another way to have the heat hit the metal so that the metal can absorb the heat. Plain and simple. And then the last one that we use is tubulars. The one on the right is a little bit older. The one on the left is actually brand new. If for some reason you're able to get inside where you could see this heat exchanger, the bad points are usually going to be right at these turns up here, and then also where these things bolt in at the top. So maybe you'll get lucky and you'll get a house that doesn't have an air conditioning system in it, and it does have a humidifier that you could pop off, or you're comfortable in popping it off, and then you could peek in there. And obviously you don't want to touch them when they're hot, but if you can move these things and wiggle them around, it's done. Plain and simple. So it's cracked, it's broken, it needs to be replaced. And heat exchangers can be replaced. They're not that difficult, on most of them to do. The only problem is when you get something that's about 20 years old and
Maybe
you
not
found a
making
bad,
it.
yeah, everything else is 20 years old. So sometimes you're better off just putting a whole new furnace in there. And I think that's what most people try to talk them into it, make everything brand new again. So, all right. So this is what a typical crack on a clamshell heat exchanger looks like. The black marks that we're seeing on this picture was flame impingement, and then this is one of our elbows or indentations that came in there. And then what happens is it tried to expand and contract and expand and contract, and obviously it ended up cracking. And sometimes these cracks, they're not all that big and not all that easy to see. All right. And on this one here, I think that's the same one we just saw earlier. That's down there. And then this front one, I want to say, is right here. This picture is blurry, but I think you could see the little smiley one right in there. And this again shows where the black is coming across, and you can see where the actual flame impingement was. So if you do get in there and you're able to pull a blower fan out, or you want to get into learning more about these things, that's how they do it. And then you get up there with the mirror and you peek up in here. Once you start seeing the black stains in there, that's where you're going to be focusing your attention in that area for the cracks. And this is just zoomed up here. Even small things like this, once they heat up, they actually start getting bigger and wider. And depending if they're at the top or the bottom, of the heat exchanger. If they're at the bottom, typically you're going to have air pressures that will push the fresh air in. But if it's at the top, you might actually be creating a Venturi effect. And if you do that, then as the air is flowing up this way, it'll actually basically, for lack of a better word, siphon the air that's inside of here and bring that into the circulation air as well, if that makes sense. All right, now the clamshell, this one actually doesn't look all that bad. Don't worry about all these scratches you see on the bottom. That was because this thing was being thrown around so much. But I want to say that was our problem child right there, where it came in here. In the days when I first started doing this, most of the heat exchangers we had were clamshells. And we actually had to get in there with a flashlight and a mirror, and we were looking around with these things. And it's not bad to have one in your tool pouch, you know. I remember I bought this 2.5-inch mirror that I could slide in here, and it's maybe about 18 inches long. I put it in a PVC tube, and I put a whole bunch of foam around it so it wouldn't break it. Needless to say, I never used it once because the first house I got to, it bounced around in my car so much, I found it broken. You know, and that was the second one I bought. The first one I bought, I didn't even get it off the airplane where it came in there. But I learned from that, you know, and you could go to a glass and mirror store, and they sell plexiglass mirror, all right, which I thought was really cool. And you could buy those and have them cut at any length and size that you want, you know. I actually went to a convention one year. We had a booth, and I think I bought like 400 of these things that were about 2 feet long, and they were 2.5 inches wide. And they were gone in like, I want to say an hour and a half, 2 hours. People just came running by the booth, grab them. Now, if I was a smart vendor, I would have been tackling them and holding on to them and made them listen to the sales pitch, but instead they just grabbed the stuff and ran away. So having a good flashlight and and I like the plexiglass mirrors, you just lay it on there and then shine the flashlight down the eyes. I usually put the tip on my nose so that the beam of the light is going the same direction that I'm looking, and then it could bounce up and you just tilt it left and right. Usually you're going to find holes and cracks in these heat exchangers in the back. Very difficult to take a picture of it, you know, but that's what we're looking at there in the back. And then the other place that's common is right up underneath where it enters. All right, so if you go inside the hole and you peek right up in there, that's typically where the other popular place is. You know, and this is what the mirror looks like when you go inside there. This was an actual mirror with, you know, plastic on the bottom. But like I said, I would try to avoid a real mirror. They're just going to break way, way too easy. There's another mirror we're trying to look up. And even if you see cracks in the face here or these things are rusted, you know, something small like that, it's pretty much done. You know, and for me, you know, even though there might not be any carbon monoxide that's coming into this, it's just a matter of time, you know, and when it's there, and I'm always afraid of the phone call when somebody says, "Why didn't you tell me about it? I could have made my own decision." You know, so anytime I see anything bad with these furnaces, I call it out. And this one, we got that obvious hole right there. So. Another way to go ahead and do this, if, again, you would almost have to remove the blower fan, or if you don't have an air conditioning unit, you can go ahead and put a bright light up in the back. And again, it's difficult to take a picture, but this white dot in here is actually a hole where the light was shining down and aiming on the back there. And that's what we were looking at. This is another clamshell heat exchanger. This is our fan limit switch, also known as the high limit switch. That little disc is actually going to have this temperature probe in here. And I guess it's nice to see this knowing that we're not measuring the air temperature inside the heat exchanger, but we're measuring the air temperature of the circulation air that's going around there. And we're going to have a data plate on this thing, and that data plate will tell you when this thing is going to go off or when it's going to trip and turn on.
Now, weren't there a number? I usually see like Honeywells that have adjustable limit switches. Is that the same idea there?
I think so, and this is one of those. You'll get that big block on here,
Yeah.
and they have the dials. And I think Honeywell was the manufacturer of the fan limit switch, and that's what that was. It wasn't just a high limit switch. It actually turned the blower fans on and off.
Right.
And I could be wrong, but I think this is actually. I know a lot of people that belong to this group want to. They're still taking their home inspector exam. And that's like one of the questions on these older things is what temperature did it turn it on? What temperature did it turn it off? What temperature did it shut down? And, it's going to be whatever the data plate says is the right answer. But, it's usually going to be the middle number. It turns the fan on. The lowest number turns the fan off. And the highest number is going to shut it down.
Over limit.
Yeah, so usually it's going to be like 100, 140, and 200, somewhere in that ballpark.
Yeah. Usually 200 is the upper limits.
Exactly, and that's when the whole furnace shuts down.
Yeah.
So what happens is the furnace is going to kick on, but they don't want to circulate cold air, so they're just going to let it get hotter and hotter and hotter before it turns the blower fan on. Typically, once it gets to 140 degrees, then it says, all right, now we can go ahead and circulate the air. And then when that's done, the thermostat is satisfied, the fire is going to turn off, but the blower fan's still going to go. Yeah. And you got all this. I mean, so that's going to keep sensing it. Once it gets down to 110 degrees or so, then it realizes there's not enough hot air to absorb and circulate through the house. And so then the blower fan shuts down. But if the blower fan is broken and or the airflow is clogged with the dirty air filter, that's when this thing is our safety feature also. And that's when it gets up to that 200 or whatever degrees and it shuts everything down. These heat exchangers, these are secondary heat exchangers that we're looking at. And these all came from Carriers. All right, I know it's upside down, but you can see Carriers here. This was common for their high efficiency units. And James, if I can impose on you to write down Carrier units manufactured 2012 and earlier. They had a known problem with their secondary heat exchangers. These things, and you can just see how that condensation from everything has just been rusting them out. And what happens is that moisture and liquid actually leaks onto the floor of the furnace. Now they end up replacing these. Each one of these slices is about $50. They've all been covered under warranty as long as it's under 10 years old. But we're at 2012 and now we're at 2022. So there's not one furnace that's really going to be covered under warranty anymore. So pretty much any Carrier furnace that's high efficiency that you're going to run into that's built from 2012 or earlier, they're going to have this problem with it. And you might as well just do everything you can to get a heating contractor out there to find this. Now there are tools that you can use, and we'll get on that stuff a little bit later. All right. And this is a close-up of that secondary heat exchanger. So if I go back, you'll see all these little slices going all the way across here. All right. Those slices are these pieces here as they're standing up. Now here on the end, you can just see all the corrosion that has happened to this one. And that actually came loose and it was starting to put CO into the circulation that came in here. Notice how they still have the same eyelets in here. I always thought that was kind of interesting. So this one up here is separated. This one is there, but it still folds everything over. And then this is a side view. This one's relatively new and in pretty decent shape when it came in there, but just to see what it looks like. So the combustion air goes in here, and then it comes out here. And these secondary heat exchangers, I mean, they're only getting us 10%. So if we go back a slide or two or three, and on this one here, we can actually see the primary heat
Wow.
exchangers. And just like, a standard 80% furnace, that's all they have are these serpentine heat exchangers in there. And they're just fine. That's still 80%. So we use the same heat exchangers for the condensing furnaces or the high efficiency ones. All we do is flip them upside down. So instead of the fire being at the bottom, the fire's now at the top and the air is coming down. And then we add the secondary heat exchanger. And that's how we get our 80% plus our 10 or more percent. And that's how we get our 90 plus. And again, another serpentine heat exchanger. You could see the pieces inside and the pieces outside that comes in there. They're just, I don't know what else to say. They're just problematic. And Carrier knew about them. And they just kept paying the technicians to repair them and replace them. But now that warranty is pretty much gone on everybody. So whoever wrote that, I can't see your name, but thank you for doing it. Again, with the Carrier secondary heat exchangers. And the biggest telltale sign, again, and I'm going to repeat it a few times, is when the furnace is running, if you get water dripping on the floor of that furnace or you start seeing stains, let it run for a while. Because if water's coming out of it, you got a hole in the heat exchanger. Even though the carbon monoxide detectors are not going off, that doesn't make it safe. You got a hole in the heat exchanger that needs to be fixed and replaced. So what they ended up doing with Carriers, they got rid of those and they started going to kind of what I like to refer to as the air conditioning coils. So we still have the same tubing and the fins in there that we run across. And again, those are only designed to get us our 10 to 15%. Now our heat comes in here and follows the serpentine pattern, comes out of here, then it goes into here, goes through our whole tubing process, and then it comes back up this way, and then it gets exhausted to the outside. If you take a close look at this heat exchanger, here we're looking at one of those eyelets where they push the two together and they crimped it on top of each other. This one is good, but if you kind of get up close to the screen at this one, I don't know if you can see the separation between the two pieces inside that circle. But that whole circle is let loose, and now this thing is opened up. And usually what's going to happen, because outside we're high pressure, inside we're low pressure or negative, so typically you're going to have fresh air going in instead of the carbon monoxide coming out. But again, any opening like that is considered dangerous, and the heat exchanger needs to be replaced. Yeah, and seeing something like this, the only way you're going to see that separation is going to be from taking the actual heat exchanger out. So that's not something we're going to be able to do. This one here, hot air started up on top. You can see the black staining, and that's where we had most of our heat hitting, and it was kind of flame impingement on this one. And I'm looking at my dimples. If we were to see underneath there, these would be the places I would be aggressive. I would be aggressive on all of these eyelets in here as well. But mostly what's going to end up failing is going to be that secondary guy. And once that thing goes, that's when I'm going to have water coming on the floor. This is a tubular one. And I mean, even with sizes of holes this big, believe it or not, this one was not letting carbon monoxide enter the living space. All right. Because these were negative inside, the air was actually flowing inwards. Now, this one you would find easily with a combustion analyzer. You would actually read the gases that are being exhausted. When we know that oxygen is needed to make a fire, we know that oxygen is going to be using anywhere from 10 to 15%. 10 to 15%. We know there's 21, roughly, percent of air that's there. That means I should be between 6, and I usually kick it up to 11. I should be between 6 and 11% of oxygen after the fire. Now, if I have more air that's blowing in here, well, now I'm going to have a higher number of oxygens. So when I get to 12 or more, then I know that I'm getting fresh air added into this thing, and then it's bad. So this is something we put in our toolbox, a combustion analyzer, and we use it on every furnace that we run into here in Chicago. Lennox, they did something that's kind of unique. They knew those eyes were the problem. So what they started doing was having the heating contractors go in there, and they actually put bolts on both sides of these things. So if you ever do peek up in there and you see bolts inside of it, that's the behind. Yeah. So these are two different pictures of heat exchangers. I think we were looking down the top on these things and trying to get in there. And I know this one here, I think on the left. So it's just so hard to take a picture because everything's so close and so far away. So this one we had a problem at the dimples. And then I think we also had a problem at one of these eyelets, but it's just not showing right here. And same thing here, we can see the eyelet is actually gone from this one. We do have a small crack on that one, and believe it or not, a small crack like that, same thing right here, is enough to say that this heat exchanger needs to be replaced. And these are also the bolts. And again, they were afraid that those eyelets were going to let loose, so they put bolts and washers around them. But you can see all we did was transfer it out a little bit. The amount of movement of these things that's needed is creating these cracks. There's a guy that he puts on a pretty good class. In fact, that's where I got most of this information from. His name is Ellis Prock, and his business is called the Heat Exchanger Experts, right? And his story is actually pretty cool. He was out in the Colorado area, and, you know, just being a typical heating guy, he would go do what he did. And he had enough experience, and he started, you know, taking pictures and seeing where these things have actually failed, and he started documenting them. So then he knew exactly what furnace he would go into, and he knew exactly where to look. Yeah, and he was able to, you know, find a crack, and even a small cracks like this, technically the heat exchanger should need to be replaced, plain and simple. Well, apparently there were a lot of heating guys that disagreed with him, and they started accusing him of just saying that a furnace is bad and calling it out there just to sell new furnaces. So they put a sting operation on him, and they had a bunch of furnaces there, and he went there on service calls, and sure enough, he found the cracks. He called them out, and then on the last one, they were waiting for him with handcuffs. All right, so they wouldn't let him during the time that he got bailed out and everything else. They did a lot of press releases, so he was in the news. His business was pretty much shut down. But once, and they wouldn't let him look at the heat exchangers to prove that he's innocent, you know, of everything. They had to wait till he get to court. And so everybody brings in their experts. He goes there, yeah, here's this heat exchanger. There's a crack, and there's a crack. And then their expert comes in there and says, yeah, those are cracks. Yep. Needs to be replaced. And of course, they put the charges on him right away, but his business was still shut down. So he ended up, you know, starting it elsewhere, and it's a shame. Really smart guy, and then he puts on classes like these now, which I think are pretty awesome. So again, with the bolt. Oh, go ahead.
So I'm just for out of curiosity, how long does it usually take add to your furnace inspection to use a combustion analyzer?
It takes us roughly 20 to 30 minutes, you know, to go on each furnace to go ahead and run this test on there. So it does add time. And then, you know, we run our business quite a bit different than most inspectors. You know, our clients pay extra for the longer, more...
It's that value.
intimate service, we'll call it. I think it has a lot of value and that, but we try to do more technically exhaustive testing, and it's my choice. Nobody else has to do that.
Sure.
That's what I want to do. So we're there 3 to 5 hours on a house. We only do one home a day. We're not going to do multiple homes, and that's it. We charge more for it, but it seems to be working, and
That is a business model.
it is, and that's all it is. And I'm not trying to push that on anyone. Please don't think I am. All right. The greatest thing about the United States of America is that freedom of choice, and everybody can do whatever they want. So
That's right.
So again, we're looking at another Serpentine heat exchanger. This gives us a good view of the secondary heat exchanger. And it's typically going to be these coils down here that are going to rot out on these. Once we get to the condensing point, and then if you look at it carefully, I think this one is bad, this one is bad, that one is bad. That one looks like a hole in it too, so we do have some issues going in on the bottom of that one there. I'm looking at my eyelets right now, and this one looks like it's got a problem. But it's really the only ones that I'm seeing on there. Maybe this one does, but I would have to be closer and live to be able to get a better look at these things. Let me go across. Just another view from the top, same type of serpentine. But this is kind of cool because it shows how everything folds over on top of each other. I kind of like this picture. Again, it's two pieces that they go ahead and put together. Same thing, rear end. On this one, we got our primary and our secondary. Primary comes in top. A lot of heat on this one. This thing is actually pretty black up in here, but I don't see too many other issues. There's a possibility that could be a crack, and that's always problems with pictures is you can't see it from a different angle. I know this is a scratch, so that's not it. You were going to say,
yeah, I'm just that had some extra heat on it. What types of conditions typically cause heat impingement?
Too high of gas pressure that's coming in there, so it's too big of a flame that's coming across, or maybe it got bumped and twisted and it's blowing the heat on one side or the other. Mm-hmm. That's also going to give you, if the flame is actually impinging and it's actually touching the heat exchanger, that's going to disrupt that flame, and that's when you're going to get those high levels of carbon monoxide.
Okay.
The tubular ones, and I'm pretty sure we mentioned this before, but the failure point is typically going to be where these things connect in here. So if you can get to them and you wiggle them, if they wiggle, it's done. If it doesn't, if it's solid, then we're still good. So again, just primary, secondary heat exchangers. The secondary one is down below. And the biggest thing you're going to see on these things when they fail is going to be water that comes in there. I'm getting all up close on my big screen in front of me here. And I'm saying that I think we got like problems in these areas here, but I'm not too sure. Obviously, we do have holes burning right there on that one. This also shows how there's two pieces and they fold over on top of each other. And these are our eyelets here, and it looks like those are gone and separated. This is just a dent. That's nothing. Another tubular one. I gotta tell you, when they pull these things out, and all of a sudden you see this thing, you're like, holy cow.
Holy cow.
It's like, that's bad. And then,
yeah, that was definitely a bad heat exchanger.
But no carbon monoxide was coming in the house. There was no way for anybody to tell things were going bad inside. All right. This one here, they just had too much oxygen coming in. Now, if we ever see stuff like a plate, and I'll show another picture of this one here in a little bit, something that we are able to see when we're doing an inspection are these screw holes
Rust.
in the bottom. Yeah. If these things are rusted or at all, then we got a problem. That means our whole secondary heat exchanger is starting to rust out as well.
For those indicators.
Yeah. And this one, I'm just trying to show how these things bend and how far they bend. And then that's why the bending point here is going to be your weak point when it comes in there.
That's really stretched.
Exactly. And just another close-up. The condensation was coming into these areas when the furnace was running. High heat, high moisture. And that was just the area that just let loose. Plain and simple. It's funny how bad this top row looks, but that second row looks pretty decent, doesn't it?
Right. Wonder how many problems occur when the A coil drip pan overflows onto stuff like that too.
Yeah, and there's really no way for us to see it either, except again if water's coming down the inside or on the floor or the blower fan. That's about the only clue, but at least it's going to go ahead and indicate something. And this is the secondary heat exchanger. These are very easy to replace. People don't realize it. All these screws are out in the open here, and they pull everything off. You can see, depending on what side it's going to be tilted, we're going to have a constant drain on both sides. This is another good clue for us, is that if you can take off or see any of this condensate that's draining, if that's got rust and crud in it, this thing is pretty much done at that point in time. That should be clear, clean liquid that's going down there. If it's dirty in any which way, you want to push that off to a heating contractor and let people know that there's a good possibility it might have to be replaced. We're not going to know, obviously, until you can pull it out and see it, and that's beyond our scope or what most people are going to do, but it is still a good indicator for us. And that's all I got. Unless you got any questions, Jason, or if anybody has a question they want to type in, I'm more than happy.
I think it was informative. I appreciate it. Appreciate your time, Charles.
I like the little chunk stuff. Small pieces, kind of get focus in here. Again, we're going to try and do these things once a week. I did have somebody ask me to do some stuff on boilers. So I think next week, if you're up for it, Jason.
That'll be fun.
Yeah, so let's do some hydronic heat systems, and we'll see if I can get enough to get some steam in there as well. And other than that, I'm going to say thank you. This video is going to stay up on our group site, and then Nachi, I know, is going to be posting these on their website as well.
All right. Thanks, everybody, joining.
Thank you. Bye-bye.